Thank you everybody for joining. My name is Get Johnson. I'm here with Calpion, a VP of sales, been in the industry for about 30 years. I want to thank you all for joining today, and I want to welcome you to our webinar. It's on how to use deep learning to make smarter decisions. I would like to introduce our moderator, Shane D'Zuzu. He's been with us for over 10 years. Shane's an associate director here at Calpion, and he's got over a decade of experience working with advanced technologies to help organizations achieve more with less. Over to you, Shane.
Thanks everybody for joining in here. So let me set the agenda for this webinar. What we are trying to achieve with this webinar is that we want to actually make CXOs more comfortable having conversations around deep learning. We want them to be able to or be armed with the information they actually require when they are actually having a talk with their technology team. Now, not just that, one of the things that has always been coming up is that a lot of people do not really understand what deep learning is, where is it applied, where the use cases that actually can be used during the application of deep learning, right? That is another thing that we'll actually be covering. Having said that, I would actually like to introduce Manish, who's here. Dr. Manish actually is going to help us understand how deep learning can actually be used in your organization with live use cases. Now, Dr. Manish is actually an author of more than probably 10 scientific publications. He is also the editorial assistant at the blog called Towards Data Science. It's one of the largest data science blogs in the world. He also comes with a decade of experience in research in data science, right? Not just that, he is actually a PhD from the University of Geneva in Switzerland. He also completed his postdoc in the University of Waterloo in Canada. Manish leads a team of machine learning engineers and scientists in Calpion. His current work uses deep learning to actually predict the gain function mutation in protein engineering using protein structure, which is basically sequential information. Now, Manish, why don't you actually tell us what's the difference between machine learning, deep learning, and AI? This is something that's been asked by multiple individuals to me. I mean, every CXO meeting that I have, this is the first thing that actually comes up. How is this different? What's deep learning? What is machine learning? And what is artificial intelligence?
Sure, Shane. Thanks for the nice introduction. I'm going to share my screen and start with the presentation. Okay. In context of this webinar, I'll be discussing mostly about the deep learning. But as you suggested, what's the difference between artificial intelligence and machine learning? That needs to be understood before we find out what deep learning is. So I will start the presentation by answering what is artificial intelligence or AI. So AI is the technology which allows a machine to take decisions. And it's basically saying what is the intelligence exhibited by machine, and that is artificial intelligence. Now, the intelligence which machine has, the decision making capability, can be of two types. One is purely algorithm based or programming based, or let's say rule based, which will give same answer in identical situation. And other is data based, where explicit programming isn't required. So we are interested in the second type of intelligence, which is data-based, and that comes under the subgroup of artificial intelligence, and this subgroup is known as machine learning. Here, all the decisions are taken by data, and when the data changes, the results changes. And within machine learning, there is another class of algorithms which are inspired by brain-like functions, or these are called neural networks. And these artificial neural networks, when they have more than 3 layers in the connection, it comes under deep neural network, and this is what we call as deep learning. Okay, so artificial intelligence is the biggest umbrella under which we see machine learning, under which we see deep learning. Now, to kind of go more deeper into deep learning, what it means, what I'm going to do is I'm going to talk about some of the architectures and some of the technical jargons which are associated with deep learning very often. So the very first deep learning architecture which we are going to see is autoencoder, or they are also known as deep belief networks. So these are the model of choice when we need to use high dimensional data and need to convert them to a lower dimension. So it's called feature reduction. And these are, or dimensionality reduction, these models are unsupervised. They don't require any labeled data. And since they are used in dimensionality reduction, they are compressing the data. So if they are compressing the data, one of the use case in which autoencoders can be used is for data compression. Just to give you an example how good autoencoders behave for data compression is, once the autoencoders were introduced, they were able to compress data 2 to 5 times better than the previous state-of-the-art algorithms which were used. Now, one thing to see or check or keep in mind here is, of course, the data compression factor given here depends upon the kind of data set being used. For some data set, compression would be more, and some data it would be less. So there is no exact compression number. So it's more or less a range, and that range holds true for data set, and it varies as the data varies. Second architecture we are going to deal with is transformers. So transformer is a relatively new architecture introduced back in 2017, and it kind of made a paradigm shift in deep learning with a concept called attention, okay, or self-attention. So what does that mean? Attention means that if that model while training will focus more on relevant data than the complete data. Okay? What does this mean? To kind of explain you this concept better, let's say we have a model which is trained to kind of identify whether the given image is cat or not a cat. And we have model A, which says that, okay, while taking the decision, the red part here is kind of important. So it kind of looks at the complete body of the cat to take this decision. So we say that attention is scattered all over the data. Well, there is another model, model B, which when given the same input image, takes the decision whether it's a cat or not. And while doing that, it just focuses its attention on the face of the cat. So it says only the face is the relevant part from which the deduction whether this is cat or not can be made. Okay, so and in the first model, the attention is kind of scattered over all the data. Second model, it's kind of on a particular feature, which is face in our case. Another example in terms of text, if we see, so if we read the sentence, the man said that the cat is sitting on the table. Here, article the is represented 3 times. So if there is a model which works on not on self-attention, what happens is when we convert these words into numbers or into some vectors which will be fed into neural network, all the 3 those will be represented by the same vector. And if you see grammatically, it doesn't make much sense because the first article the is associated with man and second is associated with cat and so on. So if we use attention, then the vector which we will get for the will be the first article the would be somehow inspired by the vector of man. So it would look something alike. And the second article the vector for that would be inspired with by the vector of cat. And that is what attention does. It kind of pays focus on the relevant part. Another network which we should look at is deep reinforcement learning. It's integration of deep learning plus reinforcement learning. And reinforcement learning is a kind of method in which learning is done by penalty and reward. So if model performs good and it gives a positive outcome, model is rewarded, while model is penalized if it gives a negative output. And this kind of algorithms are used in gaming industry, and one of the strong use case for this is self-driven cars. Okay. Next one is recurrent neural networks. So recurrent neural networks are the models which helps to preserve the temporal data, or which helps to preserve the sequential nature. So my name is Manish. This sentence make sense when these words are in specific order. If the order is changed, name is Manish Mai, this doesn't make sense. And if we want a neural network which should take all these words and also preserve the sequence, then recurrent neural network is the network of choice. And also for data, time series data, for example, if we have price of a stock which is time dependent with respect to the time, then recurrent neural network can preserve the temporal nature of the data in that case also. So it is also used for time series. At last, convolutional neural networks. These are the networks which are used when images are there. And in such cases, what happens is in such network, image is convoluted by convolutional filters. And what does that mean is there would be some filter which would be selecting out images, the edges from the image. Some some filters would be selecting only the vertical edges, some filters would be selecting only the horizontal edges, and the image which we get, the simplified version of the image which we get after convoluting it is converted into metrics, and these metrics are used in convolutional neural network. So the idea behind this slide was to introduce you with deep learning, difference between AL, ML, and DL, and also some of the technical jargon which are associated with deep learning. Hope this slide did justice with that.
Hey, thanks for that, Manish. So yeah, I've been kind of working with technology for more than a decade now, right? I've been hearing AI since eternity. I've been hearing of machine learning since eternity, but deep learning is something that's very recently come up. How relevant it is? What is the relevance of deep learning right now? Why has it now suddenly come up? What's the future prospect for deep learning? Where do you think deep learning will take us?
Okay, very correct. Like back in 2006 to 2011, when I was doing my undergraduation, deep learning wasn't a very trivial word to hear at that time, and it's right time to kind of discuss why deep learning has become important in past 1 to 2 decades, one and a half decade. The reason is evolution of computational powers. So in past 10 to 15 years, we have been introduced with GPUs, TPUs, easy accessibility of data with the help of big data, easy accessibility to store of cloud storage and cloud computational power, which is easy to access and not so expensive. And now every industry has data also to play with. That kind of gives a very correct or very right kind of environment for deep learning to flourish. And that's what has happened in last 10-15 years, and that's why deep learning is at a stage where the current market size of deep learning is around $10 billion, and it is expected to grow at a CAGR of greater than 50% for next 8 to 10 years, and will cross 400 billion mark by 2030. What does this mean physically? Physically, it means that in the next couple of years, we are going to see rise of robots, rise of drones, and some technology which uses deep learning at the back end. And more work would get automated. In terms of industry which are impacted by deep learning, the clear answer would be I frankly can't think of any industry which won't be impacted by deep learning. So that is the power. Where does we see deep learning to go in future? So now, like any other technology, this technology has some bottlenecks which needs to be improved, and a lot of research is going in that direction. For example, all the models which are made currently, they are made under the assumption of independence and identical distribution of data. What that means is when we are training the model, whatever data is used, the data is identical to whatever data we would be using for the real-time check of the model. So when model is deployed, whatever data on which it will run, that is same as the training data. And this doesn't hold true in some cases, and that's why some of the model which were performing really good on training won't perform that well while deployed. There are other such bottlenecks like contrastive learning. It can help to kind of create some vectors which can fill in the missing information. Let's say we provide an image of a house to the model, and in that house image, let's say due to some reason, windows and doors of the house are hidden. And if model is really intelligent, it can figure out with the help of contrastive learning that this place there should be a window, this place there should be a door, and then that particular data, the modified data, can be used for further analysis. Now, another buzzword which audience would hear in next 5 years is going to be system to deep learning. What does that mean is giving higher cognitive ability to machines so that they can do or perform multi-step tasks, and they can do multi-processing. And probably, as in the past 1.5 years, technological advancement has helped the deep learning to grow. Same thing will happen in next 10 to 15 years, and we will see if quantum computing allows the training, the model to be trained, then we'll see reduction in training time, and probably we will see use of some optimizers which currently we can't use. Those optimizers like Newton's algorithms we would be able to use, and these would be single step optimizers. So they would drastically change what deep learning look like now in terms of the time it is consuming to train the model. So this kind of gives you
makes sense. Yeah. So let's actually look at specific industries, right? We have a lot of audience who come from the retail industry. Retail industry is something that we interact with day in and day out, right? I mean, every day, literally, right? How do you think retail industry will actually change, or what are the use cases that are there in the retail industries for deep learning, Manish?
Sure. Cool. To begin with, so I was reading, so retail industry, the fact is that 64% of retail customers are willing to switch brands at any moment of time. So probably we can have a survey with our audience. How many of people from our audience are too particular about detergent they are using? I would guess not too many. Okay, so to kind of overcome such problems, what we can do is what retailers can do is retailer can give a customized shopping experience to the customer or to the client. What does this mean is, imagine a scenario: if customer walks into the store, when he steps in, his face image is taken by a camera, and then there is a face recognition algorithm which runs and kind of identifies, oh, this is the customer with customer ID this, and with this customer ID the retailer can search history and see like what this customer has bought in the past and at what time. And by analyzing this data, a DL model can predict what this customer is about to buy today. And once this data is with the retailer, now he can do wonders. He can upscale, so he can upsell, he can cross-sell, he can do targeted advertisement, he can do tailored promotion. And this is data only for single customer. Imagine like a retailer will have data for thousands of such customers. Then retailer can predict which item will be consumed by what time, and this kind of helps him to better manage the inventory. So this example kind of gives an idea like how holistic view of deep learning in retail industry. Similarly, it's not only retail, like other industries we talk about, maybe manufacturing. Something similar happens in that industry also, like right from the scratch, from where a factory layout is designed. Deep learning can help in better designing the factory layout so that output of the manufacturing unit is optimized. If they want to minimize the human effort that can be done using smart factory layout planning. And once the factory is running, there would be sensors on each of the machines running, and these sensors would be sending real-time data to a central computer where a deep learning algorithm would be running, and it can use the information of various features which are sent by the sensors, and it can predict which part of which machinery is going to be worn or worn next. And this kind of prognostic health monitoring tools or models can reduce the downtime of any machine. Similarly, if you look at the consumable data of the factory, there can be some deep learning model which can help to kind of forecast which consumables are going to be depleted sooner. So a better order management system can be placed in. So these are the different use cases for manufacturing industry.
Got it. So while manufacturing retail are quite the larger chunks of the industries, there are some other industries which a lot of people are very passionate about, right? For example, healthcare, you have pharma and biotech, right? Very hardcore technology companies who actually know technology but are still not able to understand how advanced technologies like deep learning can actually help them. Can you just elaborate on how or what use cases, what are the top use cases that can actually be helpful for these industries, Manish?
Sure. So health, pharma, biotech, like I have also been working with this industry for the last couple of years, and these are my personal favorite. Reason being, the deep learning impact in these industries like life altering. It can do wonders in any industry, but it can do life altering wonders in healthcare. So let's deal with these use cases. First one is remote patient monitoring. So it's a practice by which the data is collected by the healthcare industry in a non-conventional way. So imagine a person wearing a wristband, and this wristband has some sensors which can monitor the vitals of the person. Now this person falls down all of a sudden, he faints and falls down. What happens is the wristband will have fall detection, so it can detect that person has fallen down. Now it will monitor the vitals like pulse. If there is a sudden change in the pulse, or if there is a sudden change in blood pressure at the same time. And then what can happen is this band can trigger a phone call to emergency contact of this person and send them an SOS signal. maybe it can directly dial a phone to an ambulance service. So a lot of time is saved, and this can be critical in such cases. Second use case, which is there is faster drug development. Of course, during pandemic COVID, we saw vaccine which were developed as at a very rapid scale, and deep learning was somewhere involved at the back end. One of the use case which comes to my mind is there is a model called Delphi. So what it was doing was it was predicting where the next spike of the COVID is going to occur. And why was it? And it was predicting it like 3 to 4 months in advance. And why was it needed? It was needed by the vaccine development companies to kind of to start their clinical trials. So they needed this information so they can do their trials where there are likely high number of COVID patients. So using deep learning, they were able to achieve that. Identification and diagnosis of disease. Imagine there is a diagnostic lab which has data for its user for last couple of years, and using this data, doing some simple analysis on this data, the lab will be at position to predict the health of the person very precisely, and if there are any ailments which can be which can come out of the trend of the data in which the tests which are conducted, and if they suggest some trend, probably this lab would be able to kind of predict that. Protein engineering. So this is what I'm kind of doing now currently. So protein is something very vital for cell growth and metabolism. And protein is, just to explain, is something which is made up of different amino acids connected together. Now these amino acids can be changed, and this change in amino acid is known as mutation. Now, after mutation, the protein can become more functional than what it was before, or it can become less functional. In most of the cases, it becomes less functional. Now, the idea is to make such changes or to do such mutations which allow the protein to have better function. Okay, so better than before. Now, the problem is, let's say, if there is a protein of length 500, so just the single point mutation can be around 10,000 mutations can be there, or 10,000 different possibilities can be there. Not all of them is going to give you a better protein. Very rare number, a very scarce number of mutations would be there, which kind of gives a better mutation. Now, deep learn experimentally, it's very difficult. So to do 10,000 experiment to find out which one are the good mutation. But this can be done with the use of deep learning. Out of those 10,000, it can precisely pinpoint those 10, 20, 30 mutations which are the good mutations. And these good mutations are known as gain of functions mutation because it improves the function of the protein. So it's a very challenging task, and I'm kind of proud that I'm leading a team where I have phenomenal deep learning engineers who work day in, day out, and they have made this challenging task a very possible thing, and they do predict these gain of function mutation with a hit rate of 40. Like out of 100 things they're suggesting, 30 to 40 things are very true, and experimentally it's being verified. So so these are the use cases in healthcare
Great.
and biotech.
So something that's currently going on comes to mind, right? The energy crisis that's going on in Europe, right? I mean, it's something that could have been avoided, but we are here right now. Are there any use cases specifically in the energy sector the transportation sector, supply chain sector, which are actually going to be very helpful in kind of streamlining the supply chain, understanding the demand and the supply that is there within that particular environment, and not just that, to actually figure out what kind of energy sources could actually work better, right? Anything that you can actually talk about in that direction, because we do have a lot of people who have actually joined us specifically from the energy segment and the supply chain sector.
Okay, sure. So yeah, means the opportunities and limit means opportunities to use deep learning is kind of like boundless in any sector, including energy, transportation, supply chain. I'll briefly touch some of the use cases. So you asked about the problem which is currently going on. So there are many variables involved, and so deep learning can do wonders, but it's not something like it can't do magic. So yeah, correctly predicting everything, like you don't know which country is going to move what thing, and that kind of changes some variables, and yeah, predicting exactly won't be possible. But there are some algorithms for demand forecast which can predict exactly if the condition in which the data is accumulated remains the same as the current condition, then it can very precisely predict what would be the demand in future or demand now. And those can be used, but as the variables changes or as the condition changes, as I have explained, the model doesn't behave the way it should. So yeah. Second thing, like in terms of energy, like if you talk about solar or photovoltaics, maybe predictive maintenance can be used. So the solar cells have grids can have large number of solar panels, and you can imagine a drone flying over the complete grid. What it does is it takes with the help of IR camera, it takes images, and it kind of sees with the analysis of IR images, a deep learning model can help to predict which of the panels are working right and which of the panels are not working the way they should. And this again can help in kind of reducing the downtime for some part of the grid. Another use case from energy which comes to my mind is related to batteries. So now lithium-ion batteries are being used, and maybe in future some other kind of sodium-ion batteries may be used. One thing which becomes kind of critical with batteries is, like, if it's the battery from the same car company or from the same company and used by two different persons, and because of the way in which batteries are used, because of the way the batteries are charged and discharged, the battery might perform in a very different way. Maybe in one case it would last longer because it was charged and discharged according to the protocol, and in other case maybe it may discharge or it may be or become dead in lesser number of cycles. So when batteries come into the place, we have something called BMS, which battery management system, which takes information about these vitals of the batteries, and then there can be a deep learning algorithm sitting which can find or predict exactly about the life cycle of battery, how many cycles this battery is going to last if it is used in the similar way in which it is being used right now. Another example which comes to my mind for oil exploration is from the like in oil industry, there is a technique called hydraulic fracture they use. So what they do is they take water at high pressure, and it kind of targeted on shale rocks to crack them, so that whatever trapped oil in the shale rocks is there, and that starts to flow. Now the cracks or the fractures which appears on these shale rocks gives a lot of information about what should be the optimum pressure and what should be the optimum location where the exploration should be done. So there are geologists which analyze the electron microscope image of these fractures, and rather than these geologists doing this, a simple object detection algorithm can do that, and the work which is done in a couple of hours by geologists can be done within fraction of a second by deep learning based algorithm. Other use case which are there can be self-driving cars. So I think audience would it's a very common knowledge nowadays, would know a lot about it, so I'll skip this. Other can be traffic flow prediction. Maybe for a city like Bangalore, it's very useful. So traffic jam is a problem in most of the urban cities. Now, if there is a deep learning model which can model how the traffic is going to flow throughout the day or maybe for next couple of hours, then this model can be integrated with signals all over the city or in particular area of the city, and then it can basically help in better navigating the traffic. So that is one use case. Right now it's in the research stage, and I think maybe in a couple of years we can see real life use case of traffic flow predictions, and that can help mitigating the problem of traffic jam in cities to some scale.
Got it. So let's say a particular organization has now decided to kind of, use AI or deep learning within their organization, right? What are the best practices that organization needs to follow to actually make it a success, make that project a success, Dr. Manish?
Okay. So for this, I don't have any very striking answer. The thing is there are very common practices which needs to be followed very religiously, I will say. One is start early. So this can definitely give competitive advantage. And if they've started transforming, and then transform fast. So that is one. Second is, of course, deep learning model, whatever wonder it is doing those wonders because of the data. And one thing which companies, the organization should invest in is collecting the contextual data. So they should know, being the domain expert, they should know what are the things which are going to matter for a particular decision, and they should have all those data related to all those features in the data. Rule of thumb is when we give good data input, we get good result output. If we give not so good data input, we'll get not so good result output. One notion which is there in industry is more is good, or more data is good, which is not always true. I generally say that good amount of data or more data, but good data is good, but more data but rubbish data is not good. That is something to be taken care of. While building team, what one can do is build team of data scientists, of course, and along with data scientists, it's necessary to have domain expert work along with data scientists, so that they can get data scientists can get a real feel of what domain problems are, and what really the problems and the scale of the problem. These should be known to data scientists. Other thing is, one size doesn't fit all. So there is let's say, recommender engine built for retail industry, the same recommender engine cannot be fitted for some other industry. Maybe, using the data, it can be fine-tuned, and that takes time, but it's not like plug and play kind of thing. Other thing which I see is like people, when they are working on deep learning model, they do explore different things and the model interpretation. As long as model is not working, once it starts to work, they don't really care why it is working. So that shouldn't be the case. So even if model is working, it should be interpreted why it is working. Second thing is, deep learning itself has a reputation of called as black box model, because it's not very easy to explain, and it's not it cannot be explained to the scale in which other competitive algorithm like decision tree can be explained. But the thing is, at the scale which deep learning models are running, at the same complexity level, decision tree cannot be run. The other thing is, with the model interpretation, there are techniques now for deep learning model interpretation. Those should be used so that organization can know why a particular model is working good or bad. Rather than with this, like I don't have any smart pointers.
Yeah, so one of the things that I'm actually hearing from my team also, this is actually for all the attendees here, is that we're actually willing to have a 2-hour free consultation for you, where our experts can actually interact with you to actually figure out how we can solve your problems using deep learning. So you can come up with your case studies, your problems that you have within your organization, and we'll tell you whether deep learning is the solution for you, or do you need to use some other technology to achieve the end result, right? On that note, over to you, Get.
Thanks, Shane. Just want to kind of quickly introduce Thomas John. He's the president and CEO here at Calpion, Inc. Thomas brings almost 3 decades of expertise and experience in information technology and global delivery. He's an early innovator in the use of automation technology. His education includes the Executive Leadership in Healthcare program at the Harvard School of Public Health. Thomas has been a serial entrepreneur since 1998, having founded and successfully scaled many organizations. Thomas is an innovator. He's an innovative and enterprising technology executive with a strong track record of achievements. As an accomplished entrepreneur, leader, and strategist, he is recognized and respected by colleagues and clients in his ability to identify opportunities in technology, creating visions for change and growth, building and leading teams to achieve exceptional results. And with that said, it's my honor to introduce Thomas John, our CEO.
Thank you, Ged. Thank you, Shane. And thank you, Manish. Appreciate the really good conversation we had today. Just for our audience here, a quick introduction about our company, Calpion. So Calpion is been around for about 15 years. We are about 800 technology specialists worldwide, with a combined IT experience of about 3,000 plus years. We focus on performance improvement for enterprises. I mean, that's the vision that we work on, and we use technologies like AI, deep learning, machine learning, application development, RPA, and cloud, and other technologies in that realm to help our customers improve their performance as valuable enterprises in various industries that we talked about today, like retail and healthcare and pharma and so on and so forth. We our vision is to transform the ways business is done and delivery of services, leveraging automation and AI. So that's sort of how we look at it. Our team, as you have seen today with Dr. Sharma and others, have a very deep expertise around AI. So that's something that we, hope to leverage in order to help our customers improve their business outcomes. From a business point of view, we always believe that any initiative should result in ROI, and that's the ROI that we would help build for you, leveraging the technologies that we talked about today. So whether that is leveraging AI or deep learning or machine learning or all the above, we could essentially find ways to build some kind of use case and business case that would then in turn either reduce cost, improve optimized workflows, improve revenue, improve profits. All of those outcomes are what we are looking for when we work with organizations such as yours. We have happy customers across multiple industries today, whether it's biotechnology, healthcare, logistics, supply chain, manufacturing, and retail. And in all of these, we have case studies, we have best practices, we have solutions that we can talk about, and of course we can obviously customize solutions based on your needs or our clients' needs. We would be happy to use our capability to deep dive into the problems and come up with root cause issues, and then obviously apply these technologies as solutions and make them cost effective in the long run for you. So love to partner with you all. Love to talk about it as Shane suggested. We'd be happy to put together. We have a number of PhDs in this space, and one or many of them can get on a call, understand your business problems, and find ways to partner, but also provide you with some high-end or high-level solutioning on the fly on a no obligation, no cost basis. So with that, I'll turn it back to you guys. Thank you very much. Appreciate your time.
Thanks, Thomas. So we do have about 10 minutes for some questions. So if you have any questions, you can actually put them up in the chat. So I do have some questions that have already come in. So let me actually start reading them out, right? So these are for you, Manish. The first one is, when is my organization ready to work on deep learning? Interesting one.
Maybe if you are asking this question, now is the right time. So as I explained, deep learning has grown to a level where it has use cases for each industry. So once you can figure out the problem and we have relevant data, it can be answered. So if you're asking this question, I would say that this is the right time to move to deep learning. So that's the small and sweet answer.
All right. Another question that's come in is, what's the biggest challenge in data science and how do I overcome it?
Okay. The biggest challenge in data science, I would say, would be to start with it. So yeah. So as even in the previous question, you said like, what's the right time? So and this is kind of related. Like, so how to start with data science or deep learning or AI is. The organization needs to find a relevant the problem, and they need to have relevant data for that problem, using which the problem can be solved. Now, other things can be managed. Like once they have the problem, they can have a discussion with, let's say, domain expert to figure out in which area the problem lies in, whether it's in NLP, whether it's in computer vision, and which sub area of computer vision or sub area of NLP it lies in, and then probably they can start building a team around it. And so these are the main hurdles, and it takes time, but that's the way to go forward with it.
All right. Right, there's another question that's come in, which is, I'm looking to build a deep learning team within the organization. What should be my first step?
Oh, it's kind of answered in the last answer. So to build the team, one thing is if you have the problem statement ready, and you know in which area of machine learning you want to use, you can try to start building the team around that area. So that is something which you need to work upon.
All right, I think I have another answer for you there. Connect with us, we'll help you.
Fine. Yeah, sure.
And another question is, I've heard media use sentiment analysis. How accurate do you think these are?
Sentiment analysis using deep learning, so they are pretty accurate. The accuracy goes up to 98%, even higher. The thing is, again, the result depends upon kind of data set we are using. If we are using data set of simple sentences like Mike is a good boy, John is a bad boy. So it's kind of simple word where some simple sentences, not so complex, and deep learning do wonderfully well in such. Now, when you start increasing the complexity, let's say you introduce a negation. So rather than John is a bad boy, Jack is a bad boy or something, you say Jack is not good boy. If you say that, there is a negation, and because of which there is some complexity involved. I've seen deep learning model doing good with this also. And then there can be negation of negation, and deep learning can handle this. But then if you keep on increasing the complexity and you reach to a level where you have bipolar sentences, where you say, Mike is a good boy, but Jack is a bad boy. So even for a human, if you ask this question, it would become very difficult to answer whether the sentiment associated with it is good or bad, or positive or negative. Similarly, at some stage, deep learning algorithm also starts to have some kind of confusion, and they kind of starts to have, I would say, behave doesn't that well as they are expected to. But in general, if if the sentences are not complex, complexity is less, they work wonderfully well.
All right. So we'll wait for another couple of minutes for more questions to come in. Meanwhile, one of the questions that's come in is, what's the relevance of deep learning in cybersecurity?
Again, there are a number of use cases for cybersecurity which can be discussed. It's enormous. So rule of thumb is, like, cybersecurity, it's a data intensive industry. So where there is more data, there are more chances of using deep learning. So potential is enormous, and if there is a particular use case in mind, that can be discussed.
All right. So I think we are done with the questions here. Any closing notes, Manish?
Things sounds very technical and very difficult. So just to end on a lighter note, I would say when we deal with deep learning, other than what I have explained, it's more about like 80% of deep learning is, or 80% of any of the AI ML is data cleaning, and 20% is complaining about the data cleaning. So yeah. And when this ratio keeps on, it starts to change. If it becomes opposite, 20% data cleaning and 80% complaining, that is kind of a signal that you're going wrong. If it is going in other direction, it's okay.
Right. Thanks for that, Manish. So I don't think we have any other questions that have come in. Really appreciate you spending time with us, Manish. Thank you, Get. Thanks, Thomas. That was very insightful. Do connect with us if you have any questions on deep learning, on any use cases that you have within your organization, any problems that you think Calpion can solve. We're happy to hear from you. Do connect with us. Thanks, everybody. Have a great day.
Thank you, everyone.
Bye-bye.
Thanks, Shane. Thanks, everybody.